Hello everyone, and today I'm here with another integral. So this type of an integral where you have in the boundary you have infinity, this type of an integral is called improper integral. And you have some property of the improper integral which you want to know if you want to solve this problem because you have infinity. So where do you go from? From 0 to infinity? What does that mean? So for that reason, we have some property of the improper integral that we can apply in this question. So the integral from a to infinity f of x dx is defined as limit b tends to infinity integral from a to b f of x dx, where the limit exists. Right? So after we apply this given property to the integral we had, we will get this following result, which is limit b tends to infinity integral from 0 to b. In the place of infinity, we plugged in b e to the power minus x, x to the power n dx. Now, after this, how we can proceed towards the solution? So you all might know about the integration by parts concept, right? So after we use the integration by parts formula, which is integral from u dv is equal to uv minus integration v du. Now for this, we have to select what are u and what are dv. So for that reason, what we are going to say is that let us say that u is equal to x to the power n, and we take its derivative and we take the du term out, we'll get n times x to the power n dx. Okay, so now this is it. So now we have to find what is dv, and after we integrate dv, we'll get the v term. So that's pretty easy, right? So first of all, let us say dv is e to the power minus x dx. So after we represent it as that way, we'll integrate that term, and after we integrate that term, we'll get v is equal to minus e to the power minus x. So now let us summarize what we have got till now. So which is v is equal to minus e to the power minus x, du is equal to n times x to the power n minus 1 dx, and u is equal to x to the power n. Now after that, we plug in all the variables to that integration by parts formula, and we'll get the following result, which is this. So after we got this, what we are going to do is we are going to solve minus sign, plus sign, and we are going to bring the constant out of the integral sign, and that's it. Right? And this is the final equation we have right now. And after we do this, what we are going to do is we are going to multiply the whole expression with the limit, and we are going to apply the limit concept. Right? And after we do that, the first limit that we got is 0. And why is that? So this is pretty simple, right? So if you substitute in the place of x, if you substitute infinity, you'll get e to the power minus infinity, which is equal to 1 over e to the power infinity, which is equal to 1 over infinity, and that is equal to 0, right? And we have this equation as a true. So this equation satisfies. So let us have another equation. So we have another equation as well, right? So after we have this equation, we have n times integral from 0 to b e to the power minus x, x to the power n minus 1 dx. So let us bring n as a constant. We will bring that n in front of the limit sign, and after we do that, we'll be remained with only this term. And what is this term? Limit b tends to infinity integral from 0 to b e to the power minus x, x to the power n minus 1, which is equal to I n minus 1. So now look at the power of x. It's n minus 1, right? So we just substituted in the place of in, we substituted in minus 1 because we had the power. So we represented the given integral in the same way. Like for instance, we represented the integral of our equation as in is equal to integral from 0 to infinity e to the power minus x, x to the power n dx, where the power of x is in the subscript of I in the integral notation. Now what we can do is we can just relate everything, and we can say that in is equal to n times in minus 1. Now after we do that, let us integrate in minus 1 term, right? So after we integrate, so let us see what do we get after we integrate in minus 1. So is there any pattern? Is there any pattern that it follows? So we are going to find this simple thing, right? So for that reason, we are going to use the same concept, which is the integration by parts, and we are going to substitute u as x to the power n minus 1 and v as e to the power minus x, and we are going to use the same concept, and you will get the following result. And after you get the following result, we already know that limit b tends to infinity, x to the power n minus 1 times e to the power minus x tends to 0, right? That's easy. And after you have this term, you will be remained with only this term. And you have this equation. Now, if you want to solve this equation, that is pretty simple. You'll bring n minus 1 term outside of the limit. And after you do that, we can just apply the previous concept that we have used, which is the power of x, which is n minus 2. That means we'll get I n minus 2 in the subscript, right? So after we get this, we can equate everything that we have got till now, which is in as well, and in the place of in minus 1 we can substitute n minus 1 in minus 2. And after we have this, we can look at the condition of factorial, or the property of factorial, which is n factorial is equal to n times n minus 1 n minus 2 dot dot dot, it goes till it reaches 1. So what we can say from this integral is that when you integrate in minus 2, we'll get the same term. Like for instance, we'll get n minus 2 in minus 3. So it is in the same pattern of factorial. So what we can write is, we can write in is equal to n factorial. And yeah, this is the solution of this problem. And thank you for watching, and have a great day.